Okay, so let's build on the model we had before. And now I want to build something more like a platformer game, a little guy moving around, jumping like Super Mario or Meat Boy. And so this is what we have now. I can press the arrows and the ball will move up and down. If I press up, 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 it goes up. I have left, 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 left. Up, 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 up. And I press it a lot because we have gravity going on. See, so if you remember, this is gravity. So each time through the loop, stop it. Each time through the loop, I am reducing y velocity by 0.1. And the left arrow, up arrow, right arrow, and down arrow, all they do is change the appropriate velocities, right? So x velocity for the left and right, and y velocity for the up and down by plus or minus 1. So that's all we're doing. You notice the ball is not bouncing. So in the previous video, we did bouncing from the sides. Now I want to do bouncing from anything. So I want to bounce from the top and right, but also from this guy. So this is like a platform. And now you'll notice that I painted these special colors, right? So every horizontal line or border is gray. Every vertical border is red. And you see, notice this is true here. Notice if you pay attention closely there, I can show you better here. If I zoom in on the corner, maybe. So the corners are not very pretty, but yeah, so they're diagonal like that. So the idea is that every, down to the pixel, right? Every vertical pixel is red, horizontal pixel that he might come in contact with is gray. And the same over here, right? There's this diagonal. So that's important, you'll see. Okay, so to get the bouncing, first let's do bounce. So to do the bouncing, it's going to be the same as before, but now with color, right? So I'm going to have two if-thens here. I'm going to put them right after here. 1, 2, if-then. Get in there. So, and what we're going to say, if you're touching color either gray or blue. So if you're touching, you can click here, and then we're going to do the gray first. So if you're touching a horizontal surface, you remember, all I want to do is to change the y velocity to be negative, of what it is. So I'm going to set y velocity this is for the y velocity, and this one is going to be for the red, so that's going to be the x velocity. And stop it, we don't need that running. And it's just going to be negative of its current value. So that's -1 times its current value. And just -1 here. -1 times that. -1. So run that. Stop and run. So he's stuck in the middle. So boom, you have a bouncing ball. See, it bounces there, bounces against the side, against that side, top. Pretty cool, huh? You see, there's a problem. We're gonna fix soon, in a little bit, right now. But it works, right? So we have this ball that moves around, jump. So that's start. I'm gonna change this and give this guy, because this is what we want. We want a guy moving around. So I'm gonna change his costume to be the guy, and it's just gonna work the same. So I can move him left and right, and boom, boom, boom. Yeah, let's see. It's already kind of fun. You see, the problem is he's getting inside there. Okay, so a couple problems we have that we're gonna fix right now. So the first problem, this is true for whenever you're trying to do this kind of animation, is so here's the guy, right? And let's say we're gonna blow this up a little bit. So let's say he was here, and then right, he has his velocity vector. He moved here, awesome. Everything's fine, and then his velocity vector again is the same. So now he's in there. So now, if we go through this loop, we're gonna change his x velocity, y velocity. So he's gonna be in the wall. So that's a problem, right? We don't want him to be in the wall. So what we're doing now is he's in the wall, then we're changing his velocity vector. So, his velocity vector, he bounces back out. So like in this case, he would be out in the next time. But the thing is, this doesn't necessarily happen because at the same time, I could be pressing the down arrow, right? Or there's also gravity down here, right? So maybe this other vector is actually like this. So, he's still in the wall. So basically, bottom line is we do not want our guy inside the wall, right? So what we need to do is keep him outside. So we see that in terms of the programming code, right? That's gonna be happening in here, right? If he's touching the wall, then he's inside the wall. Okay. So that's one problem. Another problem, which is what if he was going like this fast? So he was here and he was going really fast. The next time he's here, so now he just went through the wall, right? Because when you're doing animation, he's never in between the 2 points. He always goes here, here. So this never fires. So this problem here, now let's solve this one problem first, and then we'll solve the other problem. This problem here can be solved by simply saying, that this cannot happen because his vector, he's never going to go that fast. Basically, we're just going to make the walls thick enough so that that never happens, right? So if you can guarantee that the vectors are only, at most this long and the walls are all at least this thick, then he's never going to go through a wall, right? And anyway, so you've probably seen this going through walls in some other video games, right? So, and this happens when you're going super fast. Now you know why. So again, the way to fix this is to bind or bound the size of the vector, and we're going to do that now. So I'm going to fix that one first. First, we're going to just put a bound on the vector. I'm going to use one of these blocks here. I'm going to make a new block called bound just to make the program prettier. And bound is easy, right? It's just a bunch of if then. So basically we're gonna say that if these, let's say x greater than, if the x velocity is bigger than our bound, which could be any number, but I'm gonna set that to 4 in this case. We can change that later. If the x velocity is bigger than 4, then I'm going to set x velocity to 4. Set, come on, x velocity to 4. And similarly, if it's less than, and for y velocity and negative x velocity. So I'm going to do that now. Okay, so I did it. So I define bound, you see it just says if x velocity is greater than 4, then set velocity to 4. If the y is bigger than 4, set y to 4. If x is less than negative 4, remember negative numbers, then we're going to set it to negative 4. So that means if x velocity is negative 5, negative 6, negative 7. And if y is less than negative 4, again set y to negative 4. So that's the bound. Pretty boring, but needed. So that means that the x and y vectors are never going to be bigger than 4. So the velocity is going to be bounded, and 4 in this case is like 4 pixels, and these walls are a lot thicker than 4 pixels. You can view it, and when you edit the custom, you can see how many pixels they are. So then we're going to call that bound. We're going to call that bound right here at the top, right? So so this way we sort of make sure that the x is never going to change by too much, right? So he's never going to move by more than that. So he's just going to be very similar to before now, except the only difference is now if I press and hold, you see I'm holding here the left arrow. Um, he doesn't go super fast as before, right? So this is also part of making a good game now. He can't go super fast, so it's actually more fun. You have more control of your guy. So I'm pressing the up arrow here. You can see there's still an issue. Like I'm gonna press up, 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 up. Okay, maybe I'll try to go up there. Left, fly, 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 fly. Ah, it's so hard. Trying to get him up. Left, okay, and left, okay, down, down, no, down, down, down. Ooh, there's the problem. You see, he's still going through walls, man. So that's the problem I talked about before, right there. See, this is exactly what's happening, right? He was down here, he went through the wall, then, I kept pressing down, and so instead of going bouncing back up, he was still in the wall because he's in the wall now, and I'm still pressing down. He's just gonna keep digging and digging inside the wall. Or maybe you want that, but mostly we don't. So how we fixed it, well, we don't want him inside the wall. It's the way to fix it. So that means that when we have this situation, we go from here to here. We definitely don't want to put him here. Now what we would want to do, I need to blow this up a little bit. Let's say this is the floor. And this was the situation here. So this is the floor here, and he would have ended up here, down here somewhere. And what we would want him is, we would want like the ball or the guy to be here, where he's just about touching the wall, right? So when this happens, we would move him back to this point. Figuring out this point is hard. So I'm not gonna do that. Instead, I'm just gonna move him back to the previous point, this one. So that's how we're gonna solve the problem. It turns out it looks pretty fine anyway. If he goes through the wall, which is in this case you're touching the color, right? So touching means you're inside the wall or partly inside, right? Could also be he moves to this point here, and he's this big, so he's partly inside, partly outside, but that's touching is true. So we're just gonna move him back to this point here, and we're still gonna calculate the vector as we are now. So basically he's just gonna go like this. From here, he's gonna go to here. Then he's gonna kind of go here temporarily, but then I'm just gonna put him right back here with this vector. So quickly move him back. So he's never really inside the wall for more than just a second. We just move him right back out, and off you go. So that's gonna mean is I'm gonna have to remember the old location before I move him to a new location. So I'm gonna need some variables. So I'm on the guy here. I am going to send some all variables. Sorry about those. I don't need those. We're going to use that in a little bit. But so right now I just have x and y velocity. So I'm going to call this the old x value, or x old for this sprite only, and the y old. That means that's the old position. What happened there? So the problem is usually the OK is on the right. I'm used to the OK button being on the right. Never mind. So it's okay, x old, y old. So I need to remember those. So I'm gonna set just before I do this, right? Which I'm gonna set. So I'm gonna set the x old to be the actually the not I don't want the velocity, I want the position, the x position. So this is x old, and the y old is the y position. So I'm remembering the old x position and the old y position, right? So that is, just before we hit the wall, this position. I'm sorry, this position. Then we go down here, or this position. We go down here. And then I move him here to the new position. Now the new position might be inside the wall. Moving around here. So the new position might be inside the wall, right? So if it's inside the wall, that means we're here. We change the y velocity, but I also want to move him back. So because he's touching gray, that means that his y position changed. So I'm gonna set y now to y old. And similarly, I am going to set x down here to x old. So I think that should be it. Let's see. Start it up again. He goes down there. And move left, right, and see, pressing the down button. Now he just keeps jumping. Right. So pretty neat trick, right? So now he shouldn't go through walls. Well, there's still, to be honest, there's still an issue, with these corners here. If you hit the corner just perfectly, there could be problems. But mostly this works. So there we go. Okay, so fly, 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 up, left, left. So this is working pretty good now. So one problem you see is my guy here is he keeps bounce. So that's not what Mario does, right? He doesn't just keep bouncing forever. So basically, we're just gonna need to add. The reason he's bouncing is because we're setting y velocity to -1 of the current velocity. So it's like perfect bounce. There's no heat loss. There's no friction. In math terms, which we love, right? A math term, right? That means that this vector and this vector are the same exact length. What we want, of course, is we want to lose, right? So when you go down, you go up, sure, but at a less speed, right? Because you just bounce. You just lost some speed to friction. And so this is simple. All we have to do is multiply. Instead of multiplying by 1, I'm going to multiply by a number less than 1. Let's say 0.5. You can play around with that. And you can see he just stopped. So press the up arrow. He goes 1, 2, 3. And he stops. So that works pretty well. And you can see he still bounces on the sides because I'm still multiplying by -1. He still bounces perfectly there, but not on these. Yeah, another thing, so that's how you get rid of the bounds. Now another thing, and I'll show, let me see, y velocity. Show the y velocity there. So you can see the y velocity and it's getting smaller and smaller. You can see it just kind of drops down to a small point there. And it's actually still probably going down. No, okay, no, that's fine. So next thing, I want to jump. So when I hit the space bar, I want to jump. That's easy enough. When I hit space, all I want to do is change the y velocity by a big number, right? So by a big positive number. So right now, when I press the up arrow, I am doing 1. So maybe 5. Although 5 is not going to work. So I'm doing 4 here anyway. So I mean, it'll work. I'm bounding it by 4 anyway. I'm going to put that there. So when I press the space bar now, he's going to go higher than the up arrow. So up arrow is like flying. Space bar is like jumping. So in the space bar, he jumps. The problem is, next problem, is that I jump and then I can hit the space bar in the air and he keeps jumping, right? So that's not really what we want, right? We want to jump only when he is on a horizontal surface, right? But one issue as we have is, so we could we could say, well, if he's touching the floor, this is what you might think. The problem is he's not touching the floor right now, even though you can see him, he's on the floor. But because we did this business here, right here, where we moved him back, remember? What we actually did was we moved him back over here in this case. So he's actually not touching the floor. Kind of looks like he is, but he is just 1 pixel above touching the floor. So he's not touching the floor. So we can't say only that the spacebar only works when he's touching the floor, because he's never touching the floor. So what we need is we need to talk about figure out when he is here, right? When he's here. And so I'm going to create a new variable, and I'm going to call it on the floor. So when is he on the floor? So this variable is going to be the value number 1 when he's on the floor, and 0 when he's not. So I'm going to set that on floor to 0. So when is he on the floor? Where if he's touching right here, when he's touching the color gray, then he's on the floor. So he's touching the color gray. That means he's under here, right? He's under the floor. We move him back, but he's still on the floor as far as we're concerned. So we're gonna set on floor to 1. Then we go through all this, do that, go back to the top, and then we change his position right here, right? So at this point here, the question is he, after we do this, so we're going to change his X and Y location. After we change his Y location, is he still on the floor? Right, well, he's going to be on the floor if his Y, basically if he moved by Y velocity. If he moves up or down, right? If he moves, then I'm just going to say, well, he's probably not on the floor anymore, right? Because he moved in the Y direction, which is going to be up or down if we're doing this the other way. So what I'm going to say here is if the Y velocity is not 0, then he's no longer on the floor. If after we move him, get in there, if then I need not, or if the y velocity is not 0, right? So it was the not equal to, if the y velocity is not 0, which means he just moved in the y direction. Then on the floor data, so he's no longer on the floor, right? And let's see if that works. So on the floor 0, and you can see 1. Press the spacebar on the floor is 0, 0, 0. He's not on the floor. 1. Oh, sorry, I moved it, so I got messed up. So let's do that again. Wow. 0 and 1. You see, 0, and he bounces. When he touches that, it quickly becomes 1. It did it 1 because he got a little bounce to him. So now on the floor is 1 only when he's on the floor. 0, 0, 0, 1. So we can use that here on the space bar here. Whoops. When space is pressed, change y velocity by 4. Well, what I really want to do is space here. Move this guy down there. We don't need him anymore. So when the space is pressed, but only if equals 0, right? If on the floor is 1, sorry, not 0. If he is on the floor. If he's on the floor, then jump. So when I press the spacebar and he's on the floor, then you jump. Otherwise, no jumpy. So that means you don't jump when you're up in the middle of the air. Jump, jump, jump. So now I can jump, but now see, pressing the spacebar now. And if I can just time it just right, I can jump right there. I can also just press and hold the spacebar because that just hits the spacebar constantly, and then he'll be jumpy, jumpy. Jump, or jump, jump, jump. Now the other thing I was going to show you, in the bound here, the other thing you want to do with the bound is, you see, one issue is like, he jumps up and down, and there's a little bit of, if you press, let's show it this way. See, if I press the X and Y, well, jump, jump, see. So it's gonna jump 2, 3, 4, 5. So the y velocity kind of gets smaller and smaller. In this case, it gets to a minimum of it seems to stop at 0.067, which is strange because it really should keep going down to 0. Anyway, you can also, just for the animation, and if you get too many little bumpies, jumps, smaller and smaller jumps, and he gets jiggly, what you do is down here in the bound, you can say if the y velocity, if it's a small number, then just make it 0, basically. That's what we're gonna do, and we're gonna do some. We're gonna use the absolute value. So it's less than, so it's going to be if the absolute value of the y velocity, or start with the x velocity, is less than, let's say 0.01 or 0.1, then just set x velocity to 0. So that way, we get rid of really small numbers, which are what make it really small velocities, which make them jiggle. So anything less than 0.1, we're just going to say 0. And the same thing for the y. So if the y velocity, the absolute value of the y velocity is less than 0.1, then set y velocity to 0. So remember, the absolute value of a number is the positive, right? So absolute value of -1 is 1. Absolute value of 1 is 1. So absolute just throws away the negative sign. It's a good function to know for programming, especially. So that shouldn't change our guy's behavior much. Just make him a little less jiggly. So you see now he can jump, jumps like that. He moves right. So see, we're getting something better. Now, okay, one last thing before I go is he this is kind of, you can see the floor is kind of slippery. He keeps going and he'll go like that forever. So you can change, that's easy enough. You can change the friction of the floor right here in the main loop. So what we want to do is, now that we have this on floor variable, we can say when he's on the floor, his x velocity is gonna get, have friction applied to it, or in vector terms. He's on the floor here. This is our guy. So he's on the floor. I guess that's star guy. He's moving horizontally. So what we want to do is, instead of leaving the x velocity alone as we're doing now, normally if you don't press anything, you keep the same x velocity. We can say if he's on the floor, then just reduce the x velocity. So if he was going at this magnitude, then next time he's going a little smaller. And basically we're adding friction to the floor. right? The way we add friction is we multiply the vector by a number less than 1, so reduce its size. We could also, you know, subtract, but multiplication works better. So we're going to do this after gravity. So here is where we add the gravity to the y velocity. We're going to say if you are on the ground, so that means if equal, we don't have Boolean variables here. If on the floor, if what is on floor is 1. So if I am on the floor, then I am going to set, or set, because I need to do multiplication, so I need to set my x velocity to x velocity times friction coefficient, which is going to be, I don't know, number between 0 and 1, let's say 0.5. So let's see how that works. So I'm going to press the X arrow. So you see he's, when I let go now, so that's a lot of friction. So you can see he can still fly on the x-axis. There's no friction in the air by the moment he hits floor, he slows down. See, pretty cool. And so 5 is kind of like a lot of friction. Maybe 0.9, it's going to reduce it by less, so that means less friction. So he's going to glide more. And you can see, so I'm going to end here. You can see, you know, I have 2 colors, gray and red, but you know, there's really no reason why just 2 colors. You could have different types of surfaces with different physics, right? So you see the gray here, which is the floor, bounces with a 0.5, and then it also has this friction. That doesn't need to be the case, right? You could also, I mean, you could have another color, another, you know, say green color, which has bounces a lot more, right? So you can have like glassy surfaces that are slippery, you know, like in Mario, you have glass surfaces. You can have bouncy surfaces like trampolines. You just have to pick a different color for each one.